Well, I'm Juan Manuel Servera. I work at Microsoft on the developer experience department. So yes, we are going to talk today about data streaming, about our product Stream Analytics. But it was about connected devices, but I prefer to talk about connected things, to connect everything to the cloud, right? So let me introduce me a little bit about myself. Well, there's a lot of I started in the industry many years ago, and well, I started in a company that we did industrial computer-aided quality management. It was about discrete manufacturing, and it was many years ago, and it was something that we did before the term IoT was coined. So we did a lot of gathering about sensors and we did a lot of analytics about all this data we were gathering. But even before that, I was very interested when I was younger, about 12 years old. I was very interested on electronics, and I was the geek guy in my school, doing things like this, burning my fingers with a soldering iron. Okay, don't do this. don't try this at home. But things have changed a lot since there, and well, nowadays when we do some kind of labs about IoT, there's something like this. Well, my colleague Isabel is here, and she organized an IoT lab, and that was the result. Just so you can see people hugging because they switched on an LED in a lab, and well, things have changed a lot since I was a child and I was trying to use a soldering iron, and now it's much easier to start creating your small prototypes about what we call nowadays IoT. So let me introduce a little bit what's IoT and how in Microsoft we see and we see the big picture about IoT, because when you talk with each provider, even if it's a device provider or a network operator, each one will talk about the IoT from their point of view, and we try to take a more holistic view about IoT and about all the things that are inside this world of the connected things and connected devices. So we start talking about what is the Internet of your things, because we don't want to change everything in your home or in your company to start an Internet of the Things project, but we start with the assets, the things you already have in your life. Okay, that's for example, the refrigerator in your house, or the elevator in the building you're working on, or your car, even your car. All these devices, all these assets, they are really gathering a lot of information. What's next is giving them connectivity, to connect it to some kind of cloud to gather all this data. But giving these devices connectivity, for giving these devices connectivity, you don't need a lot of different things. You already have a mobile phone with a Bluetooth connector, so you already have lots of things that will help you to connect all these devices to the cloud, to use all this data you are already gathering, or your devices are already gathering, to allow you to analyze all this data. So when I started in Microsoft, I started about 1.5 years ago. My manager, as he already knew that I was really working on many different projects about IoT, he told me that, we were going to publish a new version of Windows, the Windows 10 version, but it will work and it will run also inside a Raspberry Pi. So he told me that to demonstrate the power of the Windows 10 operating system, we will build a rover. So I started thinking about, okay, in Microsoft we have lots of resources, so we can create something like that, the Mars Curiosity rover. And it's something that we can demonstrate with something like that. We can demonstrate really with a lot of an autonomous robot with a lot of sensors that is sending all this data through the space. And well, I have a lot of imagination, but then we get the budget, and that's what I was allowed to build. But it's a really interesting project because it's the most simple robot you can build, and the interesting thing is running Windows 10 inside. So you can start thinking about lots of projects to demonstrate many different things about the Internet of the Things. So well, we can deploy this Windows 10 IoT Core, this special version. It's a free version. You can use it to deploy in different devices. And it has some special characteristics because it's not like the Windows you already know. It's a special version that doesn't have a shell, but you can deploy many different kinds of applications, applications with a user interface, but applications without a user interface because it's a device that where many times you will not have a screen or a keyboard or a mouse. Okay, so well, we have lots of languages, frameworks, and so on, so that you can use to create this kind of projects. But no, even if we have Windows 10 version for this, we are not thinking only about Windows, but when you create an Internet of Things project, there are many different operating systems there. There are many different kind of devices you will connect. So, our point of view is you already have a lot of data coming from your devices, from many different devices, and what we want is to make all this gathering really simple. So we have in our cloud lots of projects and lots of solutions to start from the beginning. You got a lot of producers of data, but then you need data transport to send all this data to the cloud. So we have many different services that will allow you to do this, but then you need to store all this data, you need to analyze all this data, mostly in real time, and then present it and make and close the loop, close the loop, and send all this data maybe back to the device. So you need lots of different pieces to create an Internet of the Things project. So when we are talking about an Internet of the Things project, there's an IoT project needs lots of different services. You need to collect all this data, and you need to have a system to do the data ingestion. So the data ingestion, you can do it with kind of event queuing system, like you can create a virtual machine inside the cloud with a Kafka or RabbitMQ or ActiveMQ solutions. But then you will need to think about the scale of these services. You will have to create a very big virtual network with a load balancer and so on and so on. You will have to manage all these things. No? And then when you receive all this data, you need to create some different kind of processors of this data. And many times we will need to to process this data in real time, mix it with some machine learning processes, and and many things like this. So creating an IoT solution, it's a really complex one. So what we want there is to make these kind of things simpler. So we need some of this to simplify some of these parts. For the data ingestion, we have some services like Event Hubs or IoT Hub that are already managed services, so you don't have to think about scalability nor about reliability of the system. You already will have all these things already managed for you, and you only have to think about how to send all this data to a system like this one. Event Hubs and IoT Hub are in fact an AMQP kind of message queuing system. So, and this kind of message queuing system, where you will have lots of event producers. You can have more than some millions of event producers, and then you can receive all these events inside a queue that is already partitioned for you. And you will have some, well, you have 32 partitions for this data at the beginning, but then you can ask for more partitions for this data. So why you need to partition this data? It's because when you are receiving all this data, you need to scale the way you are managing all this data. Okay, so you will have some different consumer groups, and inside each consumer group, you will be able to scale the system to process all this data in parallel. Once you are processing all this data, you can send it to different receivers, and you can have multiple consumer groups for receiving all this data easily. And then sometimes you don't only need a message queuing system. Many times you will need something much more advanced, because many times you will need to have a bidirectional communication between the device is creating all these events, the device that is connected to your assets, like for example an air conditioning system. Many times you will need to send back messages to switch on or off your air conditioning system, for example. So for this we have another service. It's called IoT Hub. The IoT Hub includes an Event Hubs queue there, but it's able to connect to create a reliable connection between the device bidirectionally. And then what you can do once you have all this data into this queue, it's connected to many different services, like for example HD Insight, that it's our Hadoop solution in the cloud. Or maybe you will need to create some real-time processes there to process all this data in real time, and finally present it in some way in one application, connect maybe with a CRM application, or present it inside a mobile device or whatever. So when you need to connect all these kind of things, you have to think about many aspects of this connectivity, because you don't only need a queue to receive, to do this data ingestion, but you need to think about different functionalities you need. There's the device-to-cloud telemetry that is the standard queue, but many times you will need to do bidirectional communication or upload bulk data to the cloud. But there's another thing that many times we forget. It's about security. How do you secure all these devices? And how do you ensure that these devices are not tampered, for example. So in the case of the IoT Hub, what we have there is we have a special key for every device. So in each device, you will have a communication channel secure for this special device. Then you need to monitor all these devices. The devices that are gathering data and sending this telemetry to the cloud sometimes will fail. And you need to know that this device has failed, and if it is receiving back the message you are sending to the device. So you need many things like that. And not only this, but you need to use a very broad different systems, because many times you will have a real-time operating system or a Linux flavor or some Windows applications like a gateway. Or maybe you will use a device that is not IP capable. Maybe you are using, well, do you know, for example, the Arduino board? The Arduino board, you cannot create an HTTPS connection because it has not the power to create an HTTPS connection. So many times you will need to use a different gateway, for example, in the a gateway inside the field or a gateway inside the cloud to create all this secure communication between the devices. No? So that's why we need something that it's much more than a simple message queue, but something that will allow to do all these kind of things. Okay, so let me demonstrate you a little bit what's the IoT Hub, and then we will talk about the streaming. That was what we wanted to talk about. So let me first show you there. Well, that's the Azure portal, and I have some. I have here there. Here an IoT Hub. The IoT Hub. Well, now I'm using a free version of the IoT Hub. We have 3 different versions. I have here a version that is able to ingest 8,000 messages a day because it's the free slot. And here I have some different devices that I have already registered inside the system. Okay. Maybe it's easier if we try to create a new one. So I go there. And for the IoT space, you can see we have many different services like HD Insight. It's the Hadoop deployment of in Azure. You can start a machine learning process there. And we have Event Hubs and IoT Hub. It's Event Hubs and IoT Hub are almost the same. And there, in the pricing and scale tier, you will see, well, I already have a free IoT Hub. It has 8,000 messages a day. But then you can create one, it's 400,000 messages a day, or 6 million messages a day by unit. But then you can create until 200 units for each service. So you will get a very powerful message queue that has bidirectional communication. Okay. So I have here a small application to demonstrate. Well, what I have here, do you know what's that? It's a multi-sensor from Texas Instruments. It has temperature sensor, humidity sensor, and so on. So I made a small application there to get this data. It's acting as a gateway for this sensor because it only communicates through Bluetooth. So I cannot connect it directly to the cloud. But if I have a mobile device, or in this case my laptop, then I can connect this sensor, and for example, well, it has an infrared sensor, so if I touch it, you see that I'm 28 degrees and almost dead there. 20, well, it takes me the temperature of the hand, and we have lots of humidity here, so well, usually I take it inside my hands and add a little humidity, but okay, we already have lots of humidity here, well, 90%. Okay, so this data, so, okay, we have infrared with this device. You have many different temperature sensors. We have one. It's the infrared of the object. You have close to the sensor. But then we have the infrared in the wall, or the temperature sensor. It's almost the same because it takes the temperature of the room. Okay, and then we have the humidity. We have 100% right now. And we have also a luxometer, magnetometer, many different things, but I'm not using all the sensors I've got there. Okay, so, well, I can take here the list of sensors I have. In this case, the sensor tag, and if you can see there, we have two different keys to access to this device, and then I can monitor the data there, and sometimes I will start receiving all the events my application is creating. I'm creating a package of JSON with all the data I'm gathering from this sensor, and I'm sending it to IoT Hub. And now with this application, I can monitor if the information is arriving to the IoT Hub. And I can also send message. Well, you can see there the JSON that I'm formatting inside my application. And I can also send messages to the device. I can send hello, just Malaga. Okay. And I can add timestamp, monitor the feedback to know if this message is being sent. So once I send, not to this device, it's to the sensor tag. Okay, send it to the sensor tag. And you can see that I'm receiving the information here. So I have bidirectional communication between, well, my laptop now is acting as a gateway, and the IoT Hub that is in the cloud, right? Okay, now I have here the message feedback that is telling me that the message arrived successfully to the device, okay? So once I've got all this information there, oh, not this one, sorry, I go there. So now that we have all this information, we have information that it's not the usual information we are used to it, because, well, when we had data before the IoT the IoT world, we had information that was stored. Okay, we could create some queries to query all this data, and in this case, well, it's lots of cars there. I can ask for how many red cars we have in this picture, for example. But nowadays, the data we are gathering with the IoT devices is data in movement. Okay, so the data in movement, when we have the data like this, we are not going to ask the same questions like we asked before. Here, we will not ask how many white cars we are seeing, but we will ask how many cars are crossing the street, or how much time the red car is taking to cross all this crossroad. And we also have noise inside this stream. We have people crossing the road, maybe a cow, whatever we have there. And we have to manage all this information, all this kind of information differently than we did before. So when we start a project like this, we had the previous picture where we had many different pieces we could use there. I suppose you already know Spark and Storm and how to deploy this kind of solution inside a Hadoop cluster. But it's a very complex thing to do usually. So we were asking, what if I could use something like a SQL language to ask similar questions to this data? So for this, we have created the Stream Analytics solution. The Stream Analytics solution, it is working with a query language very similar to SQL. And it's very easy to connect to Event Hubs or to IoT Hub or even to other kind of streaming data like blob that is being updated by a CSV file from time to time. Okay, and then we need some way to export all this data and maybe in real time inside another queue or send all this data to a Hadoop cluster or to a database. Okay, so for this we have created Stream Analytics. It's a fully managed solution that you don't have to think about how to scale it, and you don't have to think about how to reorder the events that are arriving to your system, because you will have to manage many millions of events, maybe per second, and many of these events will not arrive at the same time, but they will not arrive completely ordered. You need a system that already reorders all this data for you. So this system will do it, and the previous picture where we had many different services there, it will be much simpler. So how do we create a solution in Stream Analytics? I will open this. So let me go to my Hub solution, and we can open, well, this one, for example. So when I create a Stream Analytics that I will connect it to multiple inputs, multiple outputs, and so on, here I have the inputs of the Stream Analytics, and when I click on the inputs, I can add many different inputs for my Stream Analytics service. Okay, so here what I have, I don't see if you see it there, but it's I can connect it to a data stream or to a reference data, because many times you will have different data that you need to join it with the live data you have. And as inputs, I have IoT Hub, I have Event Hubs, but I also have blob storage. So I can use this information, but coming from different, completely different solution, because maybe I don't have a solution that is connected to the Event Hub, and I can use a message queue like AMQP protocol or the MQTT protocol, but I have a completely different solution. So we also support to use a file that it's being updated manually. Okay, and then I can have multiple outputs too. And in the outputs, I can send it again to an Event Hub, but I can use also a SQL database or table storage or Power BI or DocumentDB that it's like a MongoDB database, but managed into the cloud. Okay, so I have multiple outputs for my stream. And then I have a query. And the query, it's a simple SQL query that I have an average value, a max value, whatever. And then I have this kind of of extension to the SQL language, where I can do different time windows to allow me to create, for example, an average for a 20-second window, for example. Okay? So if I put all this, for example, I can start a stream here that it's already connected to my IoT Hub that was receiving data. So I can start the streaming. I start my application again. I connect my sensor there. Okay, this will take a while to connect. I have it connected there, and I did a little website with D3GAs. It's a very simple one to show me all this data in real time connected to this IoT Hub. So now here I have, well, my luxometer. I have the temperature. So if I just touch my device, then you can see how this information is shown in real time. Okay, and in some time that when my Stream Analytics job is started, I will start to execute all these queries I already have here. Well, they are not showing up, but well, I will show you in my presentation. And all these Stream Analytics jobs will create me some different things like the average temperature of all the system, or maybe I can create some different alerts about this information. So I will let this run a little while, and I will show you some different things you can do with Stream Analytics. At first, you see we have a query language. It's very similar to the SQL language. In fact, all these statements, select from where, group by, date name, date part, and so on, are SQL standard. But then you have the aggregate functions, and here you have some special functions like the window extensions and scaling functions that are related to the time windows. So all the data you will receive there will need to have a time field where you will work with it. Okay? So for example, we can have a tolling station where you have many cars arriving to the toll station, and you are creating all this data. You have the entry stream when the cars arrive, or the exit stream is when the cars are exiting your toll station. And you have some reference data because you can have registered all the cars by the plate. So you can see if a car has already a license to go through the toll station. Okay, so you can use a simple SQL query to filter all this data, or you can use some temporal joins because you have a SQL language. You can do joins, but in Stream Analytics you will have always the time variable inside these joins. So you will have to always provide a time window where you are working on, because if you don't provide a time window, this query will run infinitely. Okay, so let me go to the time windows there. So we have the windowing concepts that will allow you to create different kind of queries there. And we have three different ones. The tumbling window is a sequential window where you can ask what is happening inside this window. For example, you can count how many cars you have inside this 20-second window, or you may need a better window there. That's the hopping window. So you will ask how many cars are inside a 20-second window, but but give me this information every 10 seconds. So you will have a finer granularity of this information. And then we have the third kind of window, is the sliding window. So you only provide the size of the window, but this window will be always running, okay? So, and this kind of window is really useful when you need to create an event. For example, in this case, when you have more than 10 cars waiting into the toll station, then give me an alert, okay? So, using this kind of windows, what we have here, for example, just a moment. Okay, go out there. So using this kind of windows, here we have, for example, the temperature average. Well, it's not, and here we have a temperature average that you will see that it's not exactly in real time. You have a small delay because each 10 seconds I'm creating the average temperature of all this. So if I put my hand here, then I also have another query that is going to tell me if I'm over 30 degrees. You can see then that I have here an alert. So we can see the alert. I've been over 31 degrees, 31.81. So I can do all these kind of things very easily. How do we do that? Just by using this kind of queries. Just a select with having over temperature threshold, okay? So, if you want to create a demo like this, it's very easy because we already have all the information and all the code inside this website. It's going to, you can find all this information in GitHub. So you can create a solution like this, and you will have there all the queries and all the information about how to create a solution like this one. Okay, you will get lots of different sensors, not only this one, but many different ones with a Raspberry Pi or an Arduino and so on, connected to the cloud, make all the data ingestion, connect it even to real-time analytics, like and to machine learning processes. So and then how to connect this to a real-time dashboard like Power BI or different kind of dashboards there. Okay. So if you want to start with all these kind of things, you have this links, and we have the windowsondevices.com, where you will find Windows 10. You can download it for your Raspberry Pi, for example. The connecteddots.io, ThinLabs.io, it's the one that's much simpler than the connecteddots. The connecteddots is the full solution. But in the ThinLabs.io, you will find a step-by-step tutorial, so how to build things like that. And if you really want to create much complex things, we have a partnership with Hackster.io. It's a community site, and we have lots of examples there. So you can start your IoT projects. You can create your weather station or your robot, like I showed before, and things like that. So, well, thank you very much. Did you have any question? I think that we already have some time to...
If you have any questions, just catch up with, you'll be here for a few minutes afterwards, yeah. So catch up with Juan Manuel in person if you've got a few questions with him. So thank you very much.
Yeah, thank you.